So the only thing you need to do, you take the frequency, so that's group 1. Group, so this is 1, 2, 3, 4, 5. And you just label it accordingly. So here you have the count. That's the count. That's the percentage. And you calculate the percentage within that overall group. And then you do, here you have then the average and the standard deviation. Then you have here males. Males, and that's the same exercise, count, percentage. The important thing is that you recognize here what is in the numerator, because it's the count in the numerator, and it's the percentages being calculated as count over denominator, which is the overall sum of all these entries. So if this is exam 1, you're doing the same for the males, where the denominator is only the sum of all males. And for the females, the denominator is the sum of all females. The numerator is the count within the gender, within the sex. But the denominator is the number of all individuals.
What are you saying about the males and females?
So there are 2 different categories. Percentage is calculated as numerator, the count, divided by the overall number. Yeah, and the overall number for sex, male, is different than the overall number for sex and females combined, or the females. So you need to adapt the count and the numerator to the group that you're looking at.
So can I just clarify? So for the overall table, you use the count, and then the denominator is the total scores, including men and women.
Correct.
And then for each gender, I guess, separately,
Correct.
then you use the denominator of that specific
Gender, sex, yes. Correct. Correct. Yes.
If you don't want to take functions, like how should we write it? Like sort of like average or how should it be read?
Well, we're going to do the standard deviation today. It's going to become clear how to do it, right? So, you know what? You can use the functions. Use the functions. Careful, one thing. For standard deviation, do not use the standard one, the standard one. Use stdef.p. stdef.p. That is center. No, we're doing that today.
Oh, like for average, what do you want to use that?
For average is the regular average function. But then you really, okay, since I'm giving you this, which saves you a lot of work, I'm hard on the allocation. So then the percentages need to be tipped up. So I'm not going to slack any points there. So
what are we allowed to do now?
Yeah, you're allowed to use functions. You're allowed to use functions, which makes it tremendously easier. So you have stdef.p.
We can use that.
.p. There's a distinction between stdef.p and stdef.s. We're on a population level, please use p. It's on the recording, but thanks for snapshotting. Okay, we're going through that today in much detail, but this is basically the line out. So you just need to count things up, build an average of specific values and standard deviation of specific values. You just got to be careful. It's probably more an exercise of diligence than real knowledge, because this is super simple. Yes.
So is this the overall table? Or is the whole
Overall for exam 1, overall for exam 2, overall for exam 3. It's exam specific, right?
Three tables.
For these 3 tables, yes. Proportion of entries, calculate the averages, present the numbers in separate tables for each gender. So you have that in one, right? So you have overall and then each gender. And then a bar chart. And bar chart we did. Yes.
How do you want to treat the overall, like the overall?
You just do 3 tables. 3 tables in exactly that layout.
Like in your instruction says, grade frequency table below to grade 1 overall and 2 frequency table.
Yeah, and here's overall, right? So this is the overall. This is the male specific. Just pack it in one table. It's fine. So you have here one long table where you have count overall. So this is overall. overall, count, percentage, average, standard deviation. And the same for males, the same for females, and then for 3 exams. Okay?
Oh, so you don't want overall, like all of them are basically?
No, overall for all 3 exams, that's not what was meant. It was meant this overall for all genders.
So it's just 3 tables, count, percentage, average, standard
Percent.
deviation for all 3 exams.
Exactly. You just want to compare males versus females, and you want to compare to the overall results.
So
Right.
each exam have like 2 tables type? Like
Well, it's like 3 combined, right? It's overall, males, females.
For each exam, okay.
Yeah.
Do you want the scores sorted?
I don't mind.
Wait,
As long as the table is correct, I don't mind.
and like on the candidate, like how do we do it based on like male and female? Like how do you look at what?
You may want to sort it as per gender or per sex. Sorry. You want to sort it as per sex.
I know, like for example, for like.
So okay. Let's do this. So you want to do exam 1, for example. So you want to sort this now. So you go on data.
Oh, and instead of doing.
And you go on sort. So you got to be careful that you always sort the whole thing. If you only sort parts of it, and I'm flagging this, if you only sort part of it, you will only sort that particular part. If you only do a part, you're going to get mixed up with the alignment. Be careful with that. So you have headers. You sort it as per sex, A to Z. And then you go on plus. And then you can sort it by exam 1, smallest to largest. Then it will sort it first as per gender, and then secondly as per score in exam 1. If you want to do this as per exam 2, you just change this. No, you can do all at the same time. Then you sort it by exam 2.
You just keep on changing.
You just got to be careful with the sorting because it may mix up your formula. Your formula. If you have a formula in there and you start mixing it, it will lose the reference.
Sort it before you start.
You just sort it on exam 1 and then redo the same exercise without the sorting. Or copy it. Copy it like this. If you copy it that way, you can, oops. You copy A and B, and you insert copied cells here. This will give you a second alignment. So now you can sort within the exam. So you select here A to C, you sort it, and you sort it here by exam 1. Gives you here an alignment according to exam 1. If you're doing the same thing with exam 2 here, you sort it as per exam 2, and you only need the scores, right? So you only need the counts.
You want to copy paste A and B before each exam.
Exactly. That it preserves you the gender structure.
Yes.
Yep.
What is inserting it? How does inserting it help you?
Because otherwise you lose the alignment with the biological sex. If you sort this and then you sort this, so if you sort this all together, you lose here your references. So you can't do that because that screws up your formula. If you insert it here, you can just sort here these 3, and you sort within the structure of these 3 columns. That doesn't conceal the information of gender here.
So before you sort any of them, you should make a copy of each one?
Correct.
And then just sort 3 at a time. Okay, that makes sense.
Correct. Yes.
Thank you.
I think you said sorry, but are we doing separate by male and female?
Yes, we do.
But are we also doing, or do you want us to combine all 3 exams or do a chart for each separate?
For each exam separate. All right, homework. The third one follows this. The second problem follows the same layout. That should be easier, and your tutors should be familiar with that. Good. So So I hope that clarifies all questions concerning the homework. If further questions, we can correspond via discussion board. Please utilize discussion board so that so that we have one conversation as a group. I think that makes it more efficient. So today we're going to continue to do to practice standard deviation. Let's do a quick attendance. We'll get this out of the way. Okay, Noah Abisidan. Hi. Adina Adler. Hi. Kea Eshuzade. Hi. Elisa Balsam. Hi. Samantha Benjamin. Hi. Brooke Bloom. Hi. Daniel Botnick. Hi. Yehudit Cohen. Hi. Emily Dinner. Was that a wink? Hi. Kira Elbaum. Hi. Eden Ellicott. Hi. Shoshana Ellis. Hi. Shoshana Epstein. Hi. Lauren Fishman. Hi. Golda Goldberg. Hi. Emily Goldstein. Hi. Seema Greenberg. Seema? Oh, there she is. Hi. Nava Israel. Hi. Lindsay Kalish.
Hi.
Hi. Madeline Castle. Hi. Kayla Mjotavnik. Hi. Haley Orgel. Hi. Olivia Pella. Hi. Mira Postelnik. Hi. Melissa Rosen. Hi. Daniela Rothschild. Where? Oh, hi. Yes, there she is. Daniela Samuels. Hi. Sophie Schanzer. Hi. Eliana Siklik. Hi. And Ashley van Emmerongen. Oh. All right, good. So quickly back to standard deviation. So we have now, we are quite advanced. Please rewatch the recordings and go through the exercises. That will make it much easier to understand what the exercise is about. It's really just about this grouping that I'm interested in. I want you to understand the grouped frequency tables and average and standard deviation. And this is really all what this exercise is about. I want you to understand how to handle data. I want you to understand the caveats, so that the danger with data, treating data correctly, and just get your feet wet a little bit with what data management is all about. So we talked the last time about the range, which is the min to the max, so the difference between max and min. We talked about the interquartile range that basically stratifies the entire data into 4 equal parts. So that's basically the median marks the 50th percentile of the data set, whereas the first quartile is the median of the lower half, and the third quartile is the median of the upper half. And yeah, more importantly, and this is probably one of the important parameters that you learned from me. So that's the median and the mean. So that's simple, right? You've done this all in high school. You probably also heard about the standard deviation in high school, but I'm just reviewing it now because it's quite central to what we're doing. It will haunt you, because this is really the mainstay of all these principles that we will be discussing, because variability quantifies whether group means can be considered significant or not, or whether a sample is significant from a population mean, which will be the first hypothesis test that we're doing. So the most important aspect of this essentially is here the so-called variance. So variance has to do with variability, and it's basically the first most important aspect of it. And in the beginning of variance, you have the so-called sum of squares. And that sounds nice, and means we have a certain deviation, right? When you have a mean of a data series, you have a certain deviation from that mean. So you have, remember the bell curve, you have deviations that go above the mean and you have deviations that go below the mean. The deviation from that is calculated as the individual data entry, x minus the mean, x minus m. This is one deviation. So now you have a problem with that, because what is arithmetically going to be the mean of these deviations? The mean, yes, it will be negative and positive, that is true, but a perfectly symmetric distribution. Exactly, because if you make this a mean of x minus m, arithmetically, it needs to be 0 if you go back to an average of these deviations, because that's what you're subtracting it. So, and this is already one of the biggest understandings of variance, because variance basically distributes around the mean of 0, a deviation of 0. So for this very reason, you take these deviations and you square them. By that, you get x minus m multiplied by x minus m, but it will be an absolute value. So you take that negative sign and you take it off and you square it. Because -1 multiplied by -1 is +1, right? So with squaring, you get the negative sign away. So now you have for each data entry one deviation from that mean that is squared and is positive. And now you're adding this up. This is the epsilon that stands for sum as a mathematical operator. So you sum all these individual squared deviations up and you come to the sum of squares. And this is quite a central marker, essentially. This will come back with regression. This will come back with analysis of variance. This comes back repeatedly, the sum of squares. So keep that in mind. That is the formula for sum of squares. Taking the sum of squares now and dividing it by the number of entries, by the sample size n, gets you to an average squared deviation. Because you're dividing it, think of the average, right? If you wouldn't do this exercise and you would just sum these up, you would be back at 0 because your mean gets introduced here. So you square it up and then you divide it by the n. You get an average squared deviation, which is your variance. Since this is here presented already, this variance as standard deviation squared, if you want to go from this variance to standard deviation, the only thing you have to do is basically do a square root on it. You square root your variance, you get to your standard deviation. So, and we're going to do this quickly. So you have the spreadsheet. I did send the spreadsheet, right? Was an announcement. I hope it did. If not, I'll send it tonight.
Under which module?
There was the module 4. Okay, so we have here our scores. These are the Charity Navigator scores, right? So we all remember that the formula for average. So this is our average.
Would it be under?
It's module 4. Module 4. Did you find it? The Charity Navigator score?
Oh, Charity Navigator?
Yes, yes, yes. From last time.
Module 5.
Yes. Oh, module 5?
Yeah.
But chapter 4, sorry. So we're calculating the average from A2 to A, average from A2 to A41. A41. This gets you an average. So this is our average. And calculating from this now the deviation is now nothing else but A2 minus $G $2. No, 3, sorry. So you basically lock it in again, just like we always did. We're having this individual entry minus the mean locked in. And you can now just deviate it, propagate it all the way down. As you can see, Yeah, you would just go on. You just go on the right lower corner. You can propagate it all the way down. So as you can see, you get all kinds of entries here that are essentially positive and negative. Now you just sort the whole thing. You can sort it as per values, I think, which we did. So for you, it should be more values, scores, deviations, scores. We want to sort it by scores. We'll sort it from smallest to largest. So what we get now, logically and arithmetically, we get the distribution following a symmetric normal distribution by selecting both columns and go on data, sort by scores. A2 minus $G $3. So we're basically having here up until 22, we have negative values. They become then positive.
You do sort by values?
You don't have to sort anymore if you use the completed spreadsheet from last time. If not, sort by scores, please. Yes. So once you have these deviations, we're going next to square them because we need to get to the sum of squares, right? So we go to a third column, which is squared deviations.
Wait, can we?
Which don't sort if you continue with the spreadsheet from last time. Don't sort it. Just insert a column and move it to the right, which is done by clicking on a column. So just click on this column, make a right click on it, and go on insert. Push it to the right. Just to make more space, because you have the interquartile range calculations then. You just go on top of this column, you go right click, you go on insert. It will shift the whole thing without changing any formula.
I don't know how to get the finish from last time.
So then just follow along with what I'm doing here. So we're going on deviation, which is B2 to B41. So we have now these deviations from the mean. We're going now on squared deviation, which is essentially equal sign B2. And the square sign is basically this little head, which is shift 6 and 2. Shift 6. Shift 6. Let's see this. It's B2, shift 2. Let me copy the formula out. This is the formula that you want to do. This is the formula. You just make this little head. Shift 6 gives you that little head. So
For some reason, when I try sorting my data,
don't focus on the sorting. Go along with the formula. Don't worry about the sorting. Leave it as it was. Just for the sake of moving forward, we need to move.
Shift 6 and then 2.
Shift 6 and 2 gives you a squared value of that value of interest. So once you have that, you don't need to lock anything because you wanted to shift down. You double click on the right lower corner and you basically propagate this all down. So what you have now of our formula is exactly this part up there. So we have the numerator now, right?
I need to divide it by all the.
Not yet, not yet. First, we need to sum it because it's the sum of squares. So now we go all the way down and we sum this up. We go sum C2 to C41. Gives us this value, considerably large.
So how do you get equal sum? Can you write the?
This is just equal sum
Oh.
C2 to C41. Yeah.
Right.
So this is the sum of squares. Now we need now an n. The n is retrieved with count from C2 to C41 is 40, right? Now we need the variance, and the variance is now the average squared deviation. So this is basically nothing else but this value divided, and this is done with the slash, divided by the n. which gets us to 34.6.
Why is it 40, not 41?
No, it's 40.
Right.
There was a header.
Also, what was the formula for sum of squares? For some reason, mine's saying
Sum of squares is equal sign sum of this above.
sum of
C2 to C41. Sum of C2 to C41. Yes. Yep. Yes. Just repeat it again. Just go on the right lower corner. Yeah. We can look at it after this. Okay, perfect. So another way to do this, which bypasses the requirements to basically build all these exercises, is var.p. So there's a difference between p and s, which is sample or population. The difference we will discuss in later classes. But var.p basically gives you a population variance equals var.p. var.p gives you a variance on a population level rather than a sample level. Make sure that when you use this in the homework, to not use var.s or any standard functions, use var.p. Yes. You have no numbers? Well, that you need to revisit that. Just look at the recording. You'll be able to reproduce it. So var.p C2 to C41 gives you the same result, right? No, it doesn't. Why not? Oh, it's var A2 to A41, of course. So this is the same result. Yes.
Are you able to just
Yes, so you basically you have the deviation is the individual entry minus the mean locked in. So you basically you subtract the individual value from A2 to A41 from the mean, where you have to lock in the mean. You will then in the next step square that using the little hat that is essentially this formula. Equal sign B2, little hat 2, and you're dragging this all the way down to C41.
Oh.
And then you need, next you need to sum all individual errors in column C. And this sum is essentially what gets you now next to the calculation of the variance. You're dividing the sum of squares by the sample size n, and you get to the variance. This is the average squared deviation. Yep.
Would you be able to just write down the formula for variance? I can't see.
Yep. It is. This is how you calculate it. Variance.p, var.p. A2 to A41.
You also write for deviation.
Hmm?
You also write the formula for deviation as well.
Sure. This is the formula for deviation. That's deviation. This is A41, A2 to A41. You repeat this on each line minus the locked in mean. Yes. You were first. Yes.
Okay. Now your question. Just because I think I got everything until n.
N is count of each entry.
N is 40.
Correct.
So then I do something else wrong. It's okay. It's the number like that gave us originally at the start. Sorry.
Yeah.
Minus the mean.
Yes. You
Yeah.
take each entry minus the mean. Then you square that, and then you sum those squared up.
And
Yep.
divide by the count.
Correct. It's the average squared deviation.
Okay.
It's as simple. It's considerably simple. Conceptually, it sounds harder than it is. All right. Yes, please.
I think I figured after, like, when you want to get the squares of the deviation, you do read to the last thing.
Yeah, yeah,
And then 2 after that.
correct. Yes, that's square. Good. So now we are yes,
Variance is the average of square of the square deviation.
correct. It's as simple. You could hypothetically really calculate the average if you wanted to, but don't. Okay, so we have now standard deviation is now STDEF. This is now the square root SQRT of that variance. SQRT is the square root in Excel and pretty much all our applications or all other applications. So it's SQRT C46. No, we need to carry on. I'm sorry. SQRT, I refer you to the lecture recording. It's SQRT C46. Alternatively, you can also do it with STDEF.P, which is A2 to A41. Gets you the same value if you type the formula correctly. Equals STDEF.P A2 to A41. So same value, right?
What is it?
STDEF.P, that's the calculation of the standard deviation.
What is the total?
5.88. Okay, so we have this now in the lecture recording for you to revisit. So this is now the PowerPoint. We go back to the PowerPoint. So now the standard deviation gives you a standardized deviations from essentially the mean. So that's the mean of the standard deviation, right? So there's a couple of caveats that are super important in this context, and I'm flagging this for the quiz on Wednesday. Make sure that you distinguish between these two things. Just like with the average, you have a statistic and a parameter, where the statistic is being applied to a sample and the parameter applies to a population. So you have in a sample, you denote the standard deviation as SD or S, whereas in a population, you denote your standard deviation with the Greek letter sigma, which is like this little
How do we do that?
handwritten O.
Computer?
Well, you need to find it in the symbols. You will not
You
need
don't
to.
need
No, if you just write it sigma, like this, fine,
That's fine.
fine, absolutely fine. You can actually just rather focus on writing it.
Okay, thank you.
I think I wrote it a handful of times. Yeah, so it's one of those special symbols that you can insert in a Word document. You can create it. The variance is denoted as sigma squared or as SD squared, S squared. And this is also important, MS. You will find that again with the ANOVA. We will talk about MS. So it's a MS for mean squared deviations. All right, and then the square root essentially completes the entire operation, and we are now at the standard deviation. That's all it is. So essentially, as a concept, we're getting deviations. We're squaring them to get them in the realm of positive. We're taking essentially the sum of these squared deviations. We're dividing them by the number of entries. We get an average squared deviation. That's the variance. And then we're employing the square root. We get the standard deviation. It's a standardized marker of this bandwidth of the standard of this deviation around that bell curve. That's essentially what you're getting. You get mean plus minus standard deviation. That's how much it differs. So it's a marker of variability from the mean. You take the sum of squares divided by the number of entries. The square root of the variance. Yeah? All right, great. Okay, so this was all I had about standard deviation. So we caught up now with last time. So now we need to open R. And my time management with you wasn't really good. I feel a little embarrassed about that, but it is what it is. So if you go now on the practice lab, which is module 6. Please all open RStudio or the Google Colab. And now is
Open up lab one.
our studio, yes. So first we're gonna download from module 6. We're gonna download here a file that is called STAT1021 Practice Lab 1 completed. So I'm gonna make it as simple for you as possible. These practice labs are literally 3 points for you guys. You get free 10 points if you play along with me. So the reason why I'm doing it, just repeat myself, this is not for you to learn coding. This is for you to basically have some code at your disposition and have at least once in your life ran a code. So if you click on it, you will not be able to preview it or open it. You basically go on download and it will automatically download it in your Finder. Before you do anything else with that, please copy it in your respective folders. In the
Open in R, or is that better?
no, that's not good.
That's not good?
Just bring it first in the folder. So you have a folder for each module, as we have started creating these folders in the beginning. So you create a folder called module 6. And this is where you're gonna drop this code in. Now you go on our studio. Yes. What is not opening? What's not opening?
Like it doesn't open. You don't have to select something format.
No, you should, no, don't open it yet.
I shouldn't open it.
No, we said no open. No, our studio. Can you first open our studio? Only our studio.
I shouldn't open it.
No, you download it. You put it in your folder.
But when I click on the link,
Which link?
like I download it, I see the bottom.
You downloaded it and then you go in your Finder and you transfer it in your class folder. Yeah? Were you able to download it, Elias?
Yeah. I don't know.
So now you copy it over in the class folder. And from the class folder, you essentially, you rest it there in the class folder until it looks like this. You see this? You copy it in that folder. Okay?
Should copy it.
You copy it in that folder.
Yeah.
Yes, question. You're far away, it would have been difficult enough to hear you without. Okay. Can you repeat the question, please?
I was asking you to talk a little louder.
That's a good demonstration of the problem. Okay, good. Okay. Yes, I'll give my best.
Maybe you can kind of.
Maybe we should get a megaphone. Okay, yes.
I'm just struggling to. I opened up in our studio. I don't know how to get it.
We're not opening it yet, right? Did you copy it in the folder?
I don't know how to copy it.
If you copy it, it opens like.
Okay, so you already, so this is exactly why I didn't want you to open it. This is R. Can you open our studio?
I don't know, it opens two things. Like this is.
No, but you were not supposed to double click it. That's exactly my point.
I opened it on studio. I don't know what to do from here.
That looks very good. That's perfect.
I didn't see the
All right, good enough for now. We're gonna get there. Slowly but surely we're getting there. Okay, open it in our studio. Open our studio and open this from our studio. Don't double click it. That gets uncontrolled. No? What's your question?
So far, we just opened the file in our studio.
No, we didn't even open the file yet. I'm just trying to open our studio. This is where we're gonna go, but we go there systematically, please, all at once, at the same time. Okay, so we have now the folder, the file in the folder. We have now our studio. In our studio, we're going File, Open File. We go now in the folder on the desktop. We're finding our folder. And we're finding in module 6, we're finding the file. And now we're double clicking it and opening it. So now give me your error warnings. Anything else? No? You were able to open it now?
I was able to open it without doing it through the file. Like, can I just
No, go on file, please. So the point is, if you do it from the software, you have control of where you're opening it from and where it's basically residing, because it will use the internal structure of RStudio. Yes.
I'm having trouble putting it file. I opened it up.
You
I opened it in RStudio.
so it's open now. Good. So once you have here, okay. So RStudio is organized in 4 quadrants. You have 4 quadrants here. After you open it with file, you have a quadrant on the left upper corner, which is your script file. That's that script file that is populated with some things that you not yet understand, which I will explain to you. On the left lower corner, you have R. This is the actual software. This is your console. This is your console that essentially is processing whatever command you're showing it in that direction. On the right upper corner, you have the so-called environment. These are, yes, looks correct from here. But my ears are better than my eyes. I'm not sure I've seen what it just showed me, but it looked all right, yeah. Looked all right. You're fine. Just do the lecture recording, you will see. Looks good. Okay, environment, this is all recorded. That's why I'm doing these recordings, because it's just, get the class on one page is not an easy one. So we have the environment on the right upper corner. We have on the right lower corner, we have files, plots. This is where you're gonna see your graphs. You have packages which will contain those packages that we will load later on. So essentially what you will be doing first, if you look at this code that you have opened, you have here the very first line. Yes, Alasa. You are in R and not in RStudio. You need to open RStudio and then open that code. However, your code, this will also run in R. So you can run it in R if RStudio hasn't expanded. Just roll along with me, you'll see the same results. You only see that lower quadrant. You started this software, but not RStudio. Okay, we're going now to the first 2 lines. We have here a general command that will clear the entire environment. It will basically clear everything that is contained in your environment with a function that is called rm. Rm removes everything. With that list command, it basically will empty everything out that is scattered here in your environment. Everything we don't need, we delete with line 2. In principle, you're running commands by going in the line of interest, and you press Control and Enter. Control and Enter. Good suggestion. Thank you. Yeah. All right. Yeah. Much better. Okay. Control and Enter runs the respective line. If you see an error warning, don't despair. Nothing happens. Yes. You go in the line. You have left upper quadrant here. You have your functions and your lines. That we need to revisit later. Okay. You go in the respective line and you press Control and Enter. That runs the respective line. Yes.
I accidentally ran a line that I wasn't supposed to. How do I delete that?
Just go back to the second line 2 and you delete it.
I go line 2, what do I do?
You commanded Enter, yeah, runs the line. Here's the environment. Okay, so nothing happens if you just run a line. If you run these lines, nothing happens. Any questions? Yes, please. No, you stay on console. That is fine. You run line by line by line. Yes?
You can just press like this.
Yeah, you're already far ahead. You're already on the next line. But it's fine. It's fine. We get it. Yes. Control and enter. Yes. Yes, but first we do this as a team right now, one line after another. I want to give a comment to each line. Yeah, right now we start with line 1 and 2. No, it runs, it removes everything in the environment. Line 6 will load stuff in the environment, which I will explain why. Yep. No, later. Okay, let's go back to line 1. Control enter in line 1 needs to run. Okay, this is okay. We need to do this together, line by line by line. For the rest, I need to refer you to the recording. Otherwise, we're not getting through, and you don't get the practice lab through. So we want the practice lab to be completed, and you want those points, right? Yes.
How do you have their spikes?
Excuse me?
Like it says the environment and the RF spikes. How do you do that?
I'm not sure I understand the question. What do you mean twice?
I did a control enter and it says clear the environment and then RF, but you're having there twice. And you have two from the bottom.
Yes, because it's running it down in the console. You have in the console, you can rerun every line as often as you want. If you rerun, you can rerun it once you go back to that line. You will do, yes, good, very good. You go line by line down, yes. You probably are in R, you need to go in R studio. Okay. It looks perfectly fine. Yeah. No, you have the wrong code. You need to download the code completed from Canvas from module 6. That is a different problem. I can't help you with that. We need to revisit this after class. I can't do this now. Yes. Hmm? Yeah, we need to do this after. I'm sorry, I can't. No, it's okay. We need to carry on now. Okay, so now we go line by line by line through the code. You have the recordings, you have the code. If you press Control and Enter and you're just going step by line down, that is fine. It will go and process whatever line you're gonna give it to test. Yep. So with line number 6, can we please focus on step by step? We need to troubleshoot this afterwards. I can't now. Okay, so we're going through. We're loading here the data frame in that essentially will show now on the right in the environment. This is essentially the concurrent, incongruent data set that we have discussed in the context with the Stroop data. So essentially this gives you some simple commands that will allow you to look at the Stroop data. So you're running here your respective data frame. And you can do this by just going on that respective line. So if you build an object here that is then loaded in your environment here on the right, and you're clicking on the very name here in line 7, it will just run and will display this object. And now you have two further things. If you look into this object, you can with MS, with LS, for example, you can get a list of sub-objects in this object. And this basically gives you here 3 variables that are contained in your object. You have an ID, you have incongruent and congruent. You remember this from the Excel spreadsheet. Envision it like an Excel spreadsheet where you look at the columns in an Excel spreadsheet And you basically get a list of all these columns that are contained in your spreadsheet. If you just want to address one specific variable in your spreadsheet, you're separating it with a $sign, which has nothing to do with the Excel $sign. Don't get confused with that. But you're addressing it by just adding DFM2 $congruent. You only get the congruent data displayed. Not only you get it displayed, but you can also do all kinds of functions on that. So you can hypothetically also do mean for an average, mean DFM2 $congruent will basically give you a mean within one line of code. The beauty with having this set up is, you remember how complicated and convoluted it was in Excel to have like different cells that had to refer to different cells, and once you sort them, if you program this in a script like that, you have the script for eternity. And basically there's no issue with resorting, there's no issue with relining. You can always kind of refer to that very same code that will always display the data in the same fashion, and it will approach it in the same fashion. So that's the beauty of R, that basically every step can be easily documented. And it serves as a walkthrough of whatever analytic step you did. So this makes R so nice for analytic purposes, because if you work month and month and month on an analysis, you can easily reproduce every step here with your comments, where the hashtag essentially indicates here that this line will not be run, but this is just a comment where you remind yourself what that actually was, what you did down there. So this is just commenting. Yes.
Mine after congruent is my numbers after the second year. So instead of saying 1, 10, and 19 at the beginning, mine say 1, 12, 23, and then the mean afterwards are all errors.
How do you,
How
how do you get anything?
Do you have the right data file? Do you have the file that was posted in module 6?
Yeah, everything was the same up until right now.
Just go back to line 2 and run line 2, line 1 to 6 again. Just delete everything, start again, because that's also the beauty is it's easily resettable. Yes.
All of a sudden, like an error reading script, and the whole script shut down.
That's just reopen it. I don't know what you did. So just kill it and just reopen it. It's fine.
Okay, what if it still doesn't work?
Well, then we have a problem. Then we need to look at it.
So then I just can't do it.
Not the. No.
Could you scroll up a little bit in the console?
Yeah. Yes.
In the right side of the environment, you have them, but how do I get into the console? How do I get like line 7 down there?
By running it.
So I click Control Enter.
You click Control Enter, you just run it. So this is the beauty of it. You can rerun every step as often as you want.
And then I should run line 8 also.
You can run everything within the Stroop example. You can easily run. Yep. Well, I give a little bit more. Can you read this? Is this readable? I had to. So now essentially you can display it. So if this is readable still, you can also open the Zoom call. You will see it a little larger on the Zoom call. Yeah. Yeah, you need to run it again. Just run the next line. So line by line by line, you go down and you basically run every aspect and every line of it. Yep.
What's the point? What does it do?
So now we're basically, so this is just loading and displaying the data, right?
What are are we supposed to end up with?
Well, right now, so you can do here with lengths, you can count, which is useful when you do, for example, the count that we did in Excel, where you need a number of entries. You can do.
What line should we continue until?
Well, you can go all the way down as per 12. So there's dim. Dim basically gives you the dimension of this data set, which is here 24 observations and 3 variables.
Once we get to 12, we should, after 12, we should stop.
Oh, we can carry on. So we can go now on 15. Yes.
I did it again, and read it again, and I got the same problem. It says 1, 12, and 23. Mine also says.
I'm not.
How did you get that?
I also got an error.
1, 12, and 23. I'm not sure. I'm not
I
sure.
think mine, it just must have extra lines. Like it's still here, 1, 12, 23. But it's still calculated to mean the same as
Yeah, but
yours.
that's fine. Yeah.
Yeah, I don't know why.
No, no, it looks fine.
Mine looks like this, and when I tried doing it incongruent, it like says error.
Can I ask a quick question?
For me?
That's fine.
Can I just continue it?
No, you just go up and you run their respective line. So that's the beauty, right? You're programming it and you can rerun stuff very easily. Good. Well, we'll get to the deliverable for the practice lab. We're going to get to that afterwards. So we will need, so this essentially can be cleared. You can clear this entire thing with Control and L. Control and L deletes what is written in the console. You can if you want. If the error is bothering you, yes, do that. You can do it again, yeah. And that's really the beauty of R, because it's really what happens here and here, which counts. The error is just the error. You made an error. You need to understand what the ramifications of the error are, because these errors do have ramifications. Do you want to see it?
No, sorry.
No, please. I wish that screen were larger, right? So the thing is, the error that you made, as long as it doesn't have consequences in your data processing, that error doesn't matter. Like, can just be a typo.
So as long as like right top corner still looks like that top right corner, everything's okay.
Yeah. If you have those 24 observations, you're fine. So the idea is here, what I want to show you is, so you can hear, you remember how you have as a homework, you need to create subsets of males and females, right? So now to employ this now in a different shape or form, you have with the congruent and incongruent data, we tried to create like subsets of those that were smaller than 15 or 12 or whatever our threshold was. So you can do this here with that line here, which is hard to see, but I'm highlighting it just that you see it, because you can create sub-criteria by basically saying, okay, so BFM2 congruent, what I've seen before, in brackets, you're sub-specifying what entries you want to see. And you're telling it, I only want to see those where congruent is greater than 15. Yes. Yeah. So if you run this particular entry, it will only give you those entries that are greater than 15. And as a consequence of that, if you hypothetically do now, if you now would only want to do, let's say you want to do an average, you do a mean of only those that are greater than 15, you can do it with this command. So you're creating now a mean only of that subset that is greater than 15. And you can do this with one line of code. Whereas when you're going to work on the homework, this is going to be a little annoying to go through that one by one by one. Yeah. Then you calculate the mean, right? Okay. Can we all focus? There was a question which I think is quite interesting. Okay, so we can call specific columns variables in just a second. You can call specific columns or variables within your object And you can just say, okay, so this is DFM2 incongruent. I only want to look at the incongruent ones. I can, with a bracket here, which you see on line 17, 15, you can create only a smaller subset of that by basically giving it a criterion. So if you say, I only want to have the congruence now that are greater than 15 seconds, it will create automatically this subset, which is useful, for example, when you only want to have a mean of a certain subset. So for the homework example, for example, if you only wanted to have the mean of all females or males, you could easily program that in R. That's why I invite you to program the homework in R. So please surprise me, but it would be fabulous because this is how easy you can do this. An exercise like the homework, for example, that I've given you, takes you in Excel in maybe 30 minutes. In R, it takes you 5. Wait, Madeline was first.
Yeah, I was wondering what we have to transit.
Could you repeat that? Yes, we're gonna get to that later. Yes, later. We have exactly 50 minutes left. No. Okay. Quick. We're generating it, but good question, because yes, and this is why this is a standalone code. This whole code generates all this data that we have worked with. You're telling it. You're telling it. So you have here a line number 6. Can we just please focus? Thank you. Line 6.
Okay, line 6, everyone.
Line 6 creates a data frame containing all this data that you have then in your object. So the reason why I'm programmed that is because it's just easy for you guys, because I want you to play around with that. It's like whether you do it or not, it's like I want the practice lab from you as a deliverable, which we're getting to in a second. But basically, this is your sandbox. If you have any interest in programming, R programming, you have here code that stands alone, and the only thing you need to do for the practice lab, and this is now where the question comes in, what to do for the practice lab. And all please make notes now. Control and L. Clean the entire console, clean it out. Control L. Yes. Thank in the console. You click on the console, you press Control L. You click on the script. You press Command or Control A, like Adam.
Where
In the script, you select the whole thing. You select the entire script. Yes. A. Command A. And now you press Control and Enter. So.
Mine's not bad.
It is. Mine's not red.
We already done.
Mine isn't bad.
Oh.
So you have histograms, you have all kinds of graphs now. Okay, let's focus, please. So now you all go into module 6 in the folder. You go Notepad. You go on Editor. Script Editor. Script Editor. In Mac, it's called Script Editor.
How do I find that?
By typing it in the Spotlight. Spotlight here. Script Editor. Then you just make a right click in your folder, and you say New Notepad. Notepad. What's going on? Is it longer problem or a short? That's a longer problem. That's a longer problem. Just a second. Let's look at it in a second. I need to get this through, otherwise we're running out. Okay, script editor. We're opening a script. Yes. So we're opening a script editor or a notepad. Yeah, random notepad, yes. Right click and what is like? No. It's a text editor file. It's like a TXT file. Yes, you do. All right, there's like 5 voices at the same time with 5 different versions. I can't. Okay. All right, script editor. Ladies, script editor. Those of you in Windows, open please a text file.
Like a notepad?
In Notepad, perfectly fine, yes. So now you have run this code in our studio. The only thing you need to do, you ran the whole thing already. You just go at the very beginning, you got the very first line, and you just gotta make this a little smarter than I did. So you're selecting all of this. Yeah, mine either. Yeah, so selecting, I can't. So you just go all the way down. You're selecting the entire console, everything that has been run. And you press Command and C, and you copy that in your notepad. Or script editor. Okay? You have this as a recording. Now you copy, just a second. Now you copy this in your script editor and you save this. You go on File and Save. And you save it as a, you go in your folder, make sure that you're in the right folder. You need to go in the module 6 folder and you save it as a text file .txt. That's the deliverable. And you save it.
Oh yeah, what happens in that concept?
See, that's what? And we call it back as well.
Oh, okay. Why is this not working? Why is it not working? No, script editor.
And mine's syntax error.
Okay.
How do you change over? We're doing it horizontal.
Yeah. Like word? We should say it as a word.
Wrong. Script editor. Forget the script editor. Go on text editor. My bad. My mistake.
Should we say it as a word?
Text editor. Text editor. Save it as a TXT file. My bad. Text editor, not script editor. Don't try as a script editor. Go on text editor. New document. Make sure that you, okay, so there you save it in the file, save as TXT file. You save it in that folder. Text edit, and you save it as a, save it as a rich text format in, no, please don't, because then it shifts the, yeah. Save it as an RTF, as a rich text file. You can save it as a TXT file. From notes, you have it as a TXT file. Okay, save it to Word then.
What should we call it?
All right, good. We're saving this as module 6. Please label it as practice lab 1. Your family name, STAT1021F. Yeah, preferably it's a text format, but Word is fine. That's okay.
I just don't know how to, like, because then I have to do all the other stuff.
Yeah, you didn't. Did you actually copy this?
Yeah, and then
Studio 3. You haven't installed it properly. That's the problem. We need to first install this properly. Have you installed R? Have you installed R? No, R. You need R. Before R Studio, yes. You need to first install R, then R Studio. Yes.
I just want to make sure I'm doing everything right because
That's really good. That's really good.
so this is like each exam. This is for the standard deviation of all exams. I'm assuming you want standard deviation for each exam, right?
It needs to be dot P.
Oh.
P for population.
And then so you want
Oh, that's
for
very good.
each exam, all the exams. And then
Each exam,
gender,
all exam,
and then all gender.
overall, male and female. Yes?
That's standard deviation. And I'm allowed to use this function.
Yes.
Can you help me from the beginning? I'm really bad at technology. And
That's the
I
fun.
find the console.
Hmm? Yes. As a text file, preferably. You are here in R, okay? Where's R Studio? Did you install R Studio?
Yeah.
This is R. Do you have R Studio?
Yeah, I should. And it's still somewhere.
Oh yeah, that's R. But it's fine, even if you run it in R.
How do I find our studio again?
Do you have R Studio?
Yeah.
Oh wait, there, you need to drag it over here. That's our studio. Yes. Wait, sorry. Yes. Yes. Text file, yes. Your name, practice tab 1, your name and the course number. As the file, and this is what you submit to me. What? You save it accordingly to the instructions on Canvas and you submit it via Canvas. According to the instruction on Canvas, yes. Name, course number, and practice lab 1. Yes. You're not open it there. This is our studio. You need to open it with file up here to the left. Rest is in the lecture. Hmm? Yeah. Discussion board or email? No discussion board. Preferably discussion board and email. Yes. Yes, yes, yes. And send me an email reminder once you posted it.
I saved this on
Thank you.
downloads. Is it good? I saved this on downloads. Is it
Yeah, that looks all right.
Can I show you?
Sure.
So I have to, so this is what it looks like, Tax Lab 1, and then it looks like that.
Yeah, your name is missing and the course number is
So
missing.
if I should rename it, and then I should just upload file here.
Yep.
Like, or is it working?
That is late to find out.
No, so I'll tell you what happened. I have 2 computers, so the computer.
Okay,
not this
okay,
one.
okay, it's not working. Let's make it work. Okay.
I downloaded it on this one and it doesn't work. Like I downloaded it on the other one and my other one broke. That's why I had that's why I had
You need to reinstall it. Looks like a fault installation.
Yeah, every time I do it, it still doesn't work. I've done this like 5 times already.
Yeah, then you need an older version, which I have. You can find on the website. I posted an announcement with older versions. Maybe there's a version mismatch.
I looked at that. I downloaded it and it wasn't like this is but it keeps saved. It doesn't work.
Error opening. Did you install R?
Yeah. Like it's in my installation.
Yeah, so this is a little late to find out. Yeah?
No, because I just downloaded it on this one. My other one.
Oh, okay, okay. Yeah, so yeah. Yes, that looks good. Just run the whole thing. Control E and Control Enter. And copy this over in a text file. Yes.
My other one just broke like 2 days ago.
All right, good. Okay, let's make it work.
How how do I do that?
You need to find a new, more current version for our studio. First, let's confirm that you have R installed. R. So you don't have R installed. You need to first install R, and then you need to install our studio. That's why our studio is not working. It first needs R installed. Just follow the instructions that I've posted. Yeah? Yes.
It's just under this. This looks right, right?
That looks about right. Yep. All right, good.
That's what it is.
Go, really, guys. Go line for line. Try to understand what I'm giving you there. It's
It's a lot.
but you just play around. I know, and I wish we had more time to talk through this, and we will.
I heard you say that board doc is okay because my RTF wasn't
It's fine,
shown, so this is what it is.
Yeah, that's about right.
I can upload it?
Yeah.
Okay.
All right.
Thank you.
Bye. Thanks. You too. Bye bye. Yes.
Thank you. Question about quiz.
Totally what?
Like not related to
Quiz questions on the discussion board, please. Is it, what is it?
Like understanding the difference. I'm sorry. The difference between ratio and interval.
Ratio and interval.
I'm really not understanding it.
Meaningless, meaningless, a meaningful zero.
So that I get. But
Yeah.
in an example.
Temperature of cookies
Yeah.
versus a temperature of cookies can be negative something to positive something. Meaningful zero is like no cookies are left. You can't have negative cookies.
So you're coming, can't be anything lower than 0.
It can't, no. It has a meaningful zero. It's the starting point. Yeah? That's the ratio.
So they're like for amount of cookies or something, not under 0.
Correct.
Meaningful 0.
Correct.
Okay.
Yeah?
Yeah.
All right, good.
I have a question on one of the quizzes.
Yes.
For constructing a frequency table, in the notes and in the PowerPoint, it said that you first determine the highest and lowest score, but it said here the correct answer was to count the score. So I don't know
Don't
don't worry about it.
send it to me as an email. I give a general statement. It's an interesting one. Post it as on the discussion board and send me an email reminder.
Okay.
I will respond to our discussion board because that's an important conversation for everybody. Yes.
The practice lab, but I did.
Excuse me?
I uploaded the practice lab, but I did it as a text. That's what you wanted, right?
Yes,
Okay,
perfect.
okay, got it.
Good. Thank you.
Thank you.
All right. Thank you.
Thank you. Good luck, everyone. Thank you.
I think I have a TA. Great. Thank you. All right, ladies. Okay. We're going to do a quick little quiz today, right? Yes. All right. I'm sure you're excited. So
You're gonna make it available on Canva?
it is already available on Canvas. And it will also be, once I give you the password, we can, yeah?
It is time.
Yes, it's time.
Oh,
But you have plenty, you have ample of time. I go by 2 minutes a question, 2 minutes per question kind of assignment. That should give you ample time. You find whoever had accommodations, you would find that reflected on the quiz on Canvas. If you need more time, just go somewhere in the back, just relax. It's not a terrible quiz. You did the practice quizzes, you followed along, you did some reading in the chapters, you're gonna be fine. All right, okay. Good. Practice lab, always exciting. How's everybody doing? You nice and zen? Yeah, quiz, not a big deal, don't worry about it. Yes, give me a second. Okay. 6 and 7, 3. Okay, thank you, bye-bye. Thanks for your help, appreciate it. All right, quiz 1. I tend to be extraordinarily innovative and creative with my quiz passwords. This is the password of today. All right. Good luck, ladies. You won't need it. I'm sure you're well prepared.
it's on the board.
Yes, it's yes, careful, it's case sensitive. Yeah. Should be reflected on the quiz. If not, let me know. Okay.